Welcome back, everybody. And in the previous video, we learned about the two major concepts that you probably would have to learn if you've been in a chemistry class. And one of them was molarity, and the other one was molality. Okay. Let me refresh you with a couple of things before I actually would solve this particular problem. And the reason being, we learned that, well, first, again, you cannot ever forget the basic definition of what molarity is, and it's referred by an uppercase M, and that's moles of solute over a liter of solution. What students typically do is they remember the mole and they remember the liter, but they forget what it's really tagged to. Okay, and moles is tagged to the solute, the liter is tagged to the solution. In simple, you can also write it as moles over liter, right? That's molarity. Okay, this is what we've learned. And molality, okay, molality is indicated by a lowercase m, and that is essentially the same thing. The numerator is the same between the molarity and the molality, but it's just the denominator that's different. And it's 1 kilogram of solvent, and you can simply write it also as the units as mole over kilograms. Right? Now, after we learned this, we learned a couple of problems. Okay? One of them is, say, I'm just going to work out this problem right here. So, say, I give you, okay, 2 grams. I believe I worked this out. 2 grams of sodium chloride is dissolved in, right? Dissolved in, say, 50 mils of water. Okay. Now, if I don't give you the density value that will be usually provided is for the solution, okay? And we would I will be working out a problem for that. But whenever you're given grams and you're asked to find what is the molarity, okay, it's very simple. Okay, you need the two components of what a molarity is about. One is moles, another is liters, right? Well, you don't have moles, but we can certainly get the moles out of the grams here, and then we can certainly convert the milliliters to liters, because I told you again and again, I repeat, if density is not given, you're going to assume that the density of water is same as the density of the solution. So whatever be the milliliters of water you're given, you're going to convert that into liters and treat that number as the total volume of the solution. All right, if you don't believe me, take some table salt, take a clean glass of water, okay? Add a tablespoonful of sodium chloride into that water. To make it more scientific, actually mark the initial level of water and add your tablespoon of salt, or if you want, first start with a tablespoon of salt, dissolve it, and see if the mark of where the water was has changed as the water gone up. All right, if it doesn't, then that means you have not practically changed the density of the solution that much. There was probably a very, very small change, but it was not that much. So maybe add an extra tablespoon of salt, see what it does. And again, you will see that if the mark where the initial mark for the water was, if it has not changed, that means you've not apparently changed the density. And we can't be doing that every single time we're doing a problem. So sometimes we have to make a generalized assumption, and that's exactly what we did. 2 grams of sodium chloride dissolved in 50 milliliters of water. What is the molarity? Okay, whenever you're given grams and you want moles, okay, you use the molar mass conversion. Okay, I am not going to actually solve the problem because I have solved this problem in a previous video. I'm just summarizing this so I can lead you up into a wide variety of problems that you can think of based on this little concept right here. And if you're, say, given moles and you want grams, okay, you want grams, you still use molar mass, but how you put them on the tic-tac-toe box is the only thing that will differ. You know, that's why I use the tic-tac-toe box, because I think they work perfectly. Okay, same deal for molality. Okay, if I don't give you, right, assume whatever be so in this case, it will be 50 mils would become 0.05 liters. Okay, now this is for a molarity calculation, the denominator, because we are assuming the density doesn't change. Now for the molality, we're going to assume the same thing, say what is the molarity, and I'm going to also add what is the molality. Okay, the same numbers and same everything could be turned into a molality question. In that case, again, you convert your grams to moles, which will be the same, and then the molality would be, we're assuming that the density doesn't change, so 50 mils would be same as 50 grams, but keep in mind this is in kilograms, so that had to be converted to kilograms, so it'll be 0.05 kilograms, because 1,000 gram is contained in a kilogram of solvent. Similarly, 1,000 mils is contained in 1 liter. Anyways, that's kind of a quick summary of how to basically get a molar solution or a molal solution, okay? So if any of you would end up getting a job as probably a student or student intern or work study in a chem lab or some kind of a laboratory where they have you make solutions, well, this is how you do it. All right, and that's exactly what I have not quite taught you yet is what variations that we can play of the same concept. That is something that would be such a handy skill to have if you're going to go work for people and they have you make solutions ahead of time for, say, a lab or things like that. And that's exactly what we are going to learn. Okay, so let me actually get rid of this screen, okay, and bring back my original screen, and then also bring back this problem. Okay, now it's like learning how to do a basic molarity and molality calculation that I just showed in the previous screen. It's like learning how to make a basic pizza dough. You know, we've all been to pizza places where the moment we put that first piece in our mouth, we just want to get up and leave, right? That's because those people have not even perfected the dough. It's not so much the toppings, it's just the dough that's the heart of a pizza, right? Good quality pizza, it should taste good. It should have a good dough, right? So if you don't learn the basic of how to go from grams to moles and milliliters to liters, or grams to moles and grams to kilograms, to get the basic molarity and molality concept right, then there's no point for you to venture into the various, derivatives of the same concept. And this is just one of those concepts. If you look at this problem, well, first, obviously, you need to learn to read the problem. And the question reads, if the molarity of a platinum 2-chloride solution is 0.750 molar and 100 grams of platinum chloride were used to make the solution, how much of water was needed to dissolve the platinum chloride? Now, first thing first is, if you read just the way I read, it's perfectly fine if you understood the concept. But if you're somebody that struggles with any concept for that matter, in any class, I suggest you carry some color pencils with you And instead of just reading the problem like it's appearing on the above, highlight what are the given components, what are the key words, and what is that they ask you to calculate. Well, typically I underline the compound, that's my solute, and I underline the concentration that's given, which is molarity, M, uppercase M, and I underlined the mass of the substance, and then what is it asking you to do is how much water. Well, water is a liquid, so first thing first is, well, there's multiple ways to do, and I think depending on who you talk to, you might get different response for how to solve this problem. But how much is, okay, how much of water means I either can get the answer in milliliters or liters, but that's essentially what I want, right? If the molarity of a platinum 2 chloride, that's another problem. Well, first, I didn't purposefully give you the formula because I drilled you with the homework 3, and I'm never going to leave you alone with just giving you straight up formula, all right? So platinum 2 chloride, that means, well, if you've still figured out, this should be the formula. If you wonder, how did you get that? Well, that means you got to go back and look at your homework 3 one last time, right? Platinum chloride. And so important thing is you got to figure out the formula, right? Good. Now the next thing is, well, since we are dealing with molarity, it wouldn't be such a bad idea to actually write, okay, we are given molarity, right? So it's 0.750 molar. Instead of writing M, I keep telling you, while the M might be good to just identify the value, I think it's moles over 1 liter. That's what M really stands for, right? Right? That you should write it, start writing in this format, and I bet you it will be such a helpful tool to have, right? If the molarity of the solution is this, and then 100 grams were used to make the solution, how much of water was needed? Now, this is a tricky problem. Like I said, these are all setting up to do the problem. Again, as I said, if you speak to a different person, have a completely different take on how they would solve. But here's how I'm going to do it, right? So I do have this mass, right? Well, there's nothing you can do with this information now. Okay, that's just a fact. That's the final product. What can you do with the final product? In this case, probably little to nothing. So this information as it is offers nothing to get to the problem. Because you might think, hey, there's already a 1 liter, then shouldn't I answer my 1 liter? Well, guess what? I'm going to make that a multiple choice option, and so you will go for the 1 liter as the answer. If that is that easy, then why do they have to give you all this reminding information and have you figure out how much water was used? What they are really asking is, you started with 100 grams, okay, of platinum 2 chloride, and then you ended up at, when you dissolved it in so much water, you ended up with 0.75 molar. What has happened in between? That's what they want to know, right? Good. Now, as I said, first, whenever you're given grams, go get the molar mass of this platinum chloride, and I believe platinum is 197, 195, and then the 2 chlorines is roughly about 70. Okay, so 195 plus 70 is 265. So the molar mass of this compound right here is 265 grams over 1 mole. As I said, typically what you want to do when you're given grams is, well, the next logical solution is to get it into moles, right? So let's start our conversion. I think all this would make sense by the time we finish here. So 100 grams of platinum chloride. To me, that's the given information. What I treat as the given information goes in the, looks like my little line is going from Lexington to somewhere up north. So 100 grams of platinum chloride, that's my given information right there. Okay, I'm not going to bother with the line anymore. So 100 grams of platinum chloride. So there is no information, so I'm just going to put 1. Now, we do want to get rid of the grams because somehow how much I need is in milliliters or liters. So we do know that we don't want that grams in there, right? So let's go get a different color. So to get rid of the grams, as I said, you need to use the molar mass. And which goes where? Well, the 1 mole obviously goes at the top because we don't want the grams. So the 265 grams goes on the bottom. Let's go get our handy pink pen, and so that we can cancel out our grams. We're left with moles. Now, if you notice, science is all about precisely handling each ingredient at the required time. Okay, you don't want to just throw them all at one time and get chaos. All right, so you got moles. Okay, there's only one piece of information that we have not used, and that's this, right? And that's why I have conveniently written it this way, so it can now be appropriately fitted or flipped in this tic-tac-toe table. We got moles over liter, right? So obviously we can put the moles on the bottom and the liter on the top. Now the question doesn't say how much, if they wanted in milliliters or liters. If they didn't say, well, this is an extra conversion step that we don't have to do. So I'm just going to stop here at liters. But if you notice, all I'm left with is the liters, right? So it's 100 divided by 265. And then it's divided further by 0.75. So that means you started with 0.503 liters. Well, if on the test I give you liters or milliliters, I won't mix them both up. I'll usually give liters or milliliters. So this is roughly about half a liter, or if you want it in milliliters, then it's 503. It's 503 milliliters because 1,000 milliliters make up a liter. Okay, I've already given that information. So we used grams in the traditional molality problem. They always give you gram, name of the compound, and the volume, and you're asked to find out the molarity. Here you're given the mass, the concentration, and then the name of the compound, and you're asked to find the volume, right? So this is just, different variation of that pizza that I mentioned. Your direct molarity problem, like the one where you're given grams and your volume and you're asked to find the molarity, that's more like a cheese pizza, right? So when you put all that information together, you get your cheese pizza. You want to bake bacon, pepperoni, and then you want to do fancier things, then you start deviating slowly from that traditional cheese pizza, and then this is what you end up with. This is just an alternate variation. So do it systematically. Again, as I said, if you speak to anybody else, everyone will have their own take on how they write, how they present, what they think is the correct way or the ideal way. So if you've seen this information and you think, you know what, I'm going to modify it to my needs to help me decide where is my comfort zone in these type of problems, then you've got to figure it out. But if the information presented as it is seems to make complete sense and is already in your comfort zone, then that's the method for you. However, it is your job to eventually figure out what works for me. But this has worked for me, and this has worked for a lot of my students as well, because this is completely this is presented in a much simpler way. Okay, I've broken down the question into more of chemistry codes, and then I ended up solving the problem. I didn't go straight for this. I did not do this right off the bat. Okay, I have seen that done, but then maybe all those audiences were chemistry majors. Then that instructor had that privilege to do that. All right, so I'm going to stop this video here, and then I'm going to show you 2 or 3 more variations of this particular idea, and then we're going to look at an important concept called dilution, because if any of you are going to be in the medical profession, I think you just cannot bypass learning the idea of dilution. And particularly dilution in your daily life has a completely different meaning than dilution in your scientific world, because when you try to transfer that knowledge in here, there's usually a little discrepancies, and that's what gets you the wrong answer. So we're going to learn that as well, and then we're going to finish with balancing equations, and I think that will be the easiest of the bunch. So stay tuned for, I believe, 2 more videos.